So for today, we're doing things a little bit out of our order. We did 4.6 first, now we're going to go to 4.5. So in 4.5, we're going to be looking at triangles and some different theorems that we have. So we're going to look at isosceles triangle and equilateral triangles. So there's quite a bit that we're going to use. There's a number of theorems as we go forward. First of all, isosceles triangle means we have two sides that are congruent. So if our two sides are congruent, the first theorem that we're going to come across, so again, isosceles, two sides are congruent. Our vertex angle is where the two congruent legs meet. Our base angles are the legs that are that are away from or opposite our congruent sides. So that'd be the best way. So our first theorem is that in an isosceles triangle, the base angles are congruent. So this angle right here is the same as that angle there. So that's the first thing it's saying. In theorem 4.3 that you'll see, isosceles triangle theorem, is that in an isosceles triangle, our base angles are congruent. Then we go and we say the converse. If our base angles are congruent, then AB is equal to BC. So we can go either way with it. So if our base angles are congruent, our sides are congruent. If our sides are congruent, our base angles would be congruent. Next theorem that you have is if you have the bisector of the vertex angle. So if we split this into two equal parts, then it's going to be perpendicular bisector, meaning it's going to form a right angle, and it's going to split this into two equal parts. So if we bisect in an isosceles triangle, not in any triangle, but in an isosceles triangle, if we bisect the vertex angle, then it's the perpendicular bisector. So perpendicular, get two things. Perpendicular is right angle. Bisect means we cut that to two equal parts. Last two theorems to go through. If a triangle is equilateral, so if all the sides are equal, then all the angles will be equal. If all the angles are equal, all the sides are equal. Those are two corollaries to that. So if we have equal sides, we have equal angles, or if we have equal angles, then our sides are equal. Alright, so we want to explain how we know RST is an isosceles triangle. So RST is the whole thing. How do I know this whole thing is an isosceles triangle? Remember, isosceles means two sides are equal. Well, let's come down to here. Let's look at the small triangle. In this small triangle, if I know this side and this side are equal, then I know my two base angles are equal. So I can conclude that V is equal to S because it's an isosceles triangle. It's a triangle. So now I know that. Now we can go and do this. If I know, so this angle and this angle are congruent, well, I also know S and R are congruent because R was equal to V, and now V was equal to S, so S equals R. So if S equals R, then we know that our base angles are congruent. So if this angle, if S and R are equal, then we know RT and TS are equal. All right, because if our base angles are congruent, then our sides will be congruent. All right, so that's what we did. So we know that TS is equal to TR by the converse of isosceles triangle theorem. So we showed that. Now we want to go find the values of x and y. Well, let's go ahead and think about it. First of all, if you look at this angle, it's bisected. We have an isosceles triangle. This whole triangle is an isosceles triangle. And we bisected this the vertex angle. So if we bisect, it's the perpendicular bisector. So angle x is 90 degrees. So now we want to go ahead. Now that I know that this is 90 degrees. Now, if the sides are equal, what do we know about L and N? Well, L and N are equal as well. So we know L and N are 63 degrees. Now to solve for y, okay, so I know this is 90, this is 63. I need to find out this. Well, it's a triangle. In a triangle, they add the 180. So I can go 90 plus 63 plus y should equal 180. Add those together, you get 153. And then subtract 153 from 180, and you get 27 degrees. So that's how we can go about solving for that. Next one. Okay, we want to find the missing angle. So we want to solve for angle 1, angle 2, angle 3, and angle 4. Well, we'll go with the easiest one. So if you look at, again, you have an isosceles triangle right here, this triangle here. If my sides are equal, then what do we know about our base angles? They're equal. So I know angle 3 is equal to 40 degrees. Now, if I look at this triangle, this plus this should equal 180 degrees. So angle 4 plus 40 should equal 180. So 40 plus 40 is 80. Subtract that from 180, and angle 4 is 100 degrees. Now this last one here, I have an isosceles triangle. So what do we know about angle 1 and angle 2? Well, we'll first say angle 1 and angle 2 and angle 50 should equal 180. So angle 1 and angle 2, if I added them together, should be 130. I just subtracted 50 from 180. Now, these two angles, if we look at it, the sides are equal, so these two angles should be equal. So all I'm going to do is take 130 and divide it by 2. So 130 divided by 2 is 65 degrees. So each one of these angles is 65. So that's our theorem. That's what we're going to be using. You're still going to use a straight angle. You're still going to use all the theorems that we've used before. Triangle, 180 degrees in a triangle. A straight angle, if you have a straight line coming out, this plus this equals 180. Equilateral, you'd use that. If you hear the word regular, regular means all the sides are equal, all the angles are equal. So you're going to still use all of that as well. So that's our theorem for today.